Heidi ho, neighbors. It's Mr. O again, and we are going to be in Unit 3, Lesson 3, Function Graphs. We're going to take a look at a bunch of the graphs here. Just a little reminder here for you. Basically, as I said, if you give only a little bit of input, you're only going to get a little bit of an output. So while you're watching this video, don't just take notes. Make sure you're understanding them. Make sure you're using the pause button, the rewind buttons, whatever it takes. I know I go at warp speed sometimes, but we need you to do that. We want you to learn. It's critical. And if all you're doing is taking the notes, you're not really learning. So give it a shot. As you can see of my funny drawings here, I'll have different ones that we'll talk about. You'll get different shapes from the old traditional linear right here to absolute values to exponentials we're going to do this year, quadratics, and this one here actually is called a cubic root. So we're going to have some fun in this. Take the lesson, take the notes, and let's roll. Pause. We're going to go to the next slide. All right, let's see where your skills are from back in Unit 3, Lesson 2. Before I go anywhere, I want you to actually do exercise 1, and then I'm going to come through and explain it. So pause the video and see if you can find out what f of 4 is equal to, f of negative 1 is equal to, and then find out where the function is actually equal to a negative 2. All right, so pause the video. All right, let's see if you got it right. Basically, if you're taking a look here, and we go to f of 4, you have to actually count over 4. So I'm going to go over 1, 2, 3, 4. And where did it hit? Right up there. So the value of that you should have written was a 1. All right, and then if I go and take a look at f of negative 1, I actually come over here to negative 1, go up 1, 2, 3, 4, 5, and it hits up here at 6. So your value should have been 6 if you are doing it correctly. Your graph is going to be better than what I have hand drawn here. Then for part B, your job is to find out where this function here is equal to negative 2. So where is the output negative 2? Well, that means I'm looking for the y value here. I got to come down 1, 2. So where does it hit? Well, it hits right here, which means it's at the value of 1. And it also hits right here. If you count over 1, 2, 3, it comes down to negative 2. So you have two answers there. You actually have an answer where it hits at 1, and you also have an answer called 3. It actually has two inputs to give it that output. Okay? It is still a function, though, because each input still has one and only one, and it passes a vertical line test everywhere that we go. All right, part C then says state the minimum and the maximum values of this function. Now this function basically caps at a certain point. We really look at this one as more of a minimum value, and that means what's the lowest point on this thing. And if you take a look right down here, this is the minimum value. So what is the minimum value? It looks like we had to come down 1, 2, 3. So when I want to do that, I want my minimum value is going to be a negative 3. My maximum value, on the other hand, is showing that it's going here and it keeps going, and it's going on forever that way. It's going on forever that way. They did not give us a specific interval to go in, so what we want to do is say, hey, on this case, the maximum value for this thing is it actually goes on forever, and we write the symbol infinity. So it goes on forever, okay? Pause at the moment. We're going to go to the next slide. Now we're going to go on to exercise 2A. Basically, they tell us that the function is g of x here is equal to 2x plus 3, meaning we twice the input and add 3 to it every time. So we're going to fill out the table, and all that means is plug this over here in. We've got to take the negative 3 right here and plug it in. So we do 2 times a negative 3 plus 3. And that should give you an output then of, you got a negative 6 here on the first part, plus 3 is a negative 3. And they have the final table here, so you actually say, hey, I put in a negative 3, I got out a negative 3. Let's do another one here. The next one I take 2, and now this time I'm going to input negative 2 and plus 3. And what I get now from here is negative 4 plus 3 is a negative 1. So if I put in negative 2, I actually get a negative 1 as my output. All right, pause the video now and finish the rest of that table. All right, thank you for coming back. The table here now we're going to go through. The next one you should have gotten actually a -1 would actually turn out to be a 1. And then 0 would actually have turned out to be 3. And then 1 should have come out as a 5. And then 2 as a 7. And 3 as a 9. Okay, how did I get that? Well, if you take a look right here, you can see that this is going up 1 every time. And I see nothing in my pattern. You should recognize that as a linear function. So each one of these should be constant as well. And if you notice, they keep going up by 2, so it's quick to figure out. All right, now we're going to turn around. We're going to graph that on the next slide. All right, so now we're going to graph the table we just did. And the first point, of course, is a -3. And I got to go down 3 right here. So I will put a point at -3, 3. Then I actually had a -2, and if you remember, they were going up by 2, so that's -1. -1 is +1. 0 was up 3 here. I can't quite see that. Then 1 up 5, 2 up 7, and 3 was up 9. Okay. Finally, my job is connect the dots here. If I do that, put my little arrowhead on it. This year, make sure you get used to graphing, right? So your label. So I'm going to do g of x equals 2x plus 3. Must label the lines, must label your axes and stuff. And you should at least tell me a couple little points going out. So if I actually go out, that's like a 5, and I go this way, it's a -5, etc., and up 5, and down 5. Okay? Make sure you label everything properly. Get full credit for this. All right, we're going to move on now to exercise 3. All right, now in exercise 3, we've got a new function we're going to deal with. The function is basically just x squared. You're going to learn that that's actually called a quadratic. Now, unfortunately, I'm limited on my technology again, so you will see me put x raised to the second power. Some of you use that little caret button right here on your calculators to mean the powers too, so it means the same thing out in our real world here. So I'm going to actually plug in -3 here, so that means I take the -3. And keep in mind, the entire thing is being squared, so we should know -3 squared is 9, which means our coordinate is a -3, 9 on the first one. If I plug in a -2 next, you get that's equal to -2 times -2 is +4, so -2 comes out at 4. Pause the video now for a moment, and I want you to fill in the rest of the table. All right, now that you're back, let's see if you got the same answers. -1 actually turned out to be 1. 0 turned out to be 0. 1 also turns out to be 1. If you notice, these two match up. 2 matches up with 4, so you'll notice that these guys match up. And 3 turns out to be 9. You'll notice these guys match up. That's what specific happens in a quadratic. When we get to that unit, we'll talk a lot more about that. But these are our numbers, so now we're going to go to the next page, and we're going to graph them. All right, so let's take our function of x squared, and let's graph this. You remember -3 actually turned out to go over here 3 to the left, and we have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again, it'll probably help if I actually labeled a few of these things ahead of time. So I'm going to count up 1, 2, 3, 4, 5 here and put a 5. And I'll go 5 to the left. And I'll go 5 to the right, and down 5. Should be good. So, -3, I got to go up 9. So it's 5, 6, 7, 8, 9. I'm going to put a point right there, okay? Then we said -2 was actually up 4. Then we said that -1 is up 1. 0 is at 0. And now watch what happens. 1 is at 1. 2 is at 4. 3 is at 3. And now if I connect these, do not play connect the dot on these. We actually have a curved figure. You see it turning. It's not do straight lines. So I'm going to actually curve this thing a little bit here. Come around. Up we go. Put your arrowheads on. State your function, which was f of x was equal to x squared. And this is the parent function, the most basic quadratic there is. So you basically were able just to pick that one out. So you can graph all kinds of things that you may have never thought you could graph before. Okay, next page. All right, the unique function you're going to see this year is going to be called a piecewise function. And if you take a look at this thing here has 2 pieces to it. F of x is equal to 2x plus 6 whenever x is less than 0. And this one has 6 minus x when x is greater than or equal to 0. Notice I had to create the little equal to bar there. They don't give me that as an option either in the technology of this. So we got two things to do, but you got to watch out. The key is going to be around 0, and we're going to have two things. If you notice, they're both linear, so they're going to change. So let's start plugging this one in. -3 is the first one I have to plug in. Does -3 less than 0, or is it bigger than or equal to 0? Of course, it's less than 0. So you need to throw it in the equation. 2 times the x, so that's our input, -3, plus 6. Well, obviously, when you do that, you'll get a -6 plus 6, which means that thing turns out to be 0. So -3, 0 is our point. And then -2, we do 2 times -2 plus 6, and you will end up getting here, let's see, -4 plus 6 is 2, so -2 is 2. Then when you do -1, you get 2 times -1 plus 6, and that thing will turn out to be -2 plus 6 is 4, so -1 is 4. You see the pattern going, but we have to watch out now for a second, because at 0, life changes. Anything less than 0 was this equation. That was all of these items right here. I'm going to change things here. So I'm going to put a little dotted line across here. And life is now going to change. So if I go back here, now I'm going to use this 6 minus x for anything bigger. So if we take a look here, 0 obviously is greater than or equal to 0. So I got to do 6 minus 0. So I have to change it, which of course is equal to 6. So that's going to be 0, 6 as a point. Then I have to do 6 minus 1, so that's 5, etc. And you'll keep going like this. You'll get 1, 5. And if you notice the pattern, 2 will turn out to be 4 if I did the work, and 3 will turn out to be 3. Now we're ready to look at this thing on the graph. We're going to actually plot it on the next one and see what a piecewise function looks like. All right, so let's plot this baby. Basically, like we said, -3 is at 0 right here. -2 was up at 2. -1 was up at 4 we had. And then we shifted gears. 0 turned up to be up here at 6. But it was a different function. So now you're going to see a change in this. 1 turned up to be 5. And you see how this thing's starting to turn down. 2 was at 4. And 3 was at 3. So when I do this function, I'm not going to put arrowheads on it because it's not going on. Well, actually, it does go on forever. My bad. We should put arrowheads on it. But it turns, and there's two pieces to this graph. All right. So you would have to write the full thing here, that f of x equals, and then it depends where things are. You've got the 2x plus 3 whenever x is less than 0. And you have the 6 minus x when x is greater than or equal to 0, okay? And that is your function. But the bottom line is you get two pieces out of it. Both of these pieces, one for one part when you're 0 or bigger, and one for anything less than 0. And we're going to see a bunch of those. That's a totally new thing to New York State here. As of the last couple of years, we really haven't hit that before, okay? So we will move on. Make sure you write a nice WSQ tonight. You got your notes set. Make sure you understand it. Rewind, pause, whatever you got to do. And we'll talk to you in class tomorrow.